So in this video I'm going to discuss the whole GFG today's interview session. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I provide both the links in the comment section. I will pin them. So actually I have completed all the 3 GFG problems which occurred in today's interview series. Okay, so the first question is range OR. That is, you're given a number n and you have to find the OR of all the numbers from 1 to n. Okay, so that is 1 or 2 or 3 or dot 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 till n. So 1 for n equals to 3, so 1 or 2 or 3 is 3. For n is equals to 1, 1. Okay, so answer is 1. So the basic formula that you need to know is this one, that is 2 to the power log 2 base n plus 1 minus 1. Okay, this is the basic formula that you need to know. So what we can do, let's say we are making a variable temp where we are going to store log 2n plus 1. Okay, log 2n plus 1. There is a function in I think Python, CPP, most of the programming languages provide this thing, log 2. Okay, and once done with it, then you can make temp is equal to power of 2 comma temp. That is, first of all this was temp, now this whole thing is temp. Okay, and then we can return temp minus 1, that is returning the whole thing. Okay, so this was the first one. This was a very easy code. Okay, so okay, let me tell you why it happens. So if you check one thing, okay, if I write all the numbers from 1 to n, so that becomes 1, 2, it is in binary representation. Okay, 3, 4, 5, 6, 7, 8, and so on, right? So see, for 1 it is 1, right? For the first 2 it becomes 2, and for the first 3 also it becomes 2. But when we go to this third one, it becomes 7, right? So if we notice one thing, it is not 3, 2, it is 3. Okay, so if you notice one thing, it is either becoming 1 or 3 or 7. That is, it is 2 to the power let's not say n, let's say m minus 1. Okay, it is of this pattern. But we have to know that what is the value of m, right? What is the value of m? So for 1, the value of m is 1, right? For 1, the value of m is 1. For 2 and 3, the value of m is 2. Okay, for 2 and 3. So if you notice this thing very carefully, see, log 2 base 1 is equal to 0, and 0 plus 1 is 1. Log 2 base 2 is equal to 1, and log 2 base 3 is also equal to 1, and both, if we add with 1, it becomes 1. But once we make log 2 base 4, this becomes 2, right? That is the point when we are going to find 7. The answer is becoming 7, right? So that is the logic. Okay, so that is the reason why we made log 2n, and this plus 1 is because of this thing that we are adding 1 to this, and then we are going to make 2 to the power that thing, because 2 to the power m, right? 2 to the power m and minus 1. So this is where the formula comes from. Okay, like if you see the pattern, for 1 this is happening, for the rest 2 this is happening. For the first one it is 1, for the first 3 it is 3, for the first 7 it is 7, and then for the next, and it goes on like that. Okay, so this is what the basic thing is. Like a valid proof can also be drawn from this, that is 1 and 1 0 makes it 1 1, and till you go to 1 0 0, this 0 0 has already been covered with 1. Okay, so that becomes 1 1 1, then 1 1 1, then 1 1 1, and so on goes. And again, when this becomes 0 0 0, all these ones have been covered earlier, so that becomes 1 1 1 1. Okay, so this is the basic logic. So this was the first one. The second one, let's say, it's the Mex Array thing. If you know the Mex thing, okay, it states that the first non-negative number which does not occur in an array. Okay, that is what Mex means actually. So over here you're given an array, and this is the size of the array. So what you have to do is you have to find out a way of arranging the array. First you have to arrange the array into any of its permutation, and you have to find out the max of the first sub array from 0 to 0, then from 0 to 1, then from 0 to 3. Okay, that's the thing. That is, let's say if the array is a0, a1, a2, so max of 0 is the first non-negative integer which does not occur in this one, in this part. Okay, then max of 1 will be the first non-negative integer that occurs in this one, does not occur in this one. The first non-negative integer does not occur in this one. This is what it means. So the most optimal way is to arrange this array in descending order. Okay, arrange this array in descending order. So what we are going to do, actually we are going to arrange it in ascending order. Okay, then traverse from the back, which also makes a similar sense. So if we sort array A, then k is equal to 0. I will tell you why. Then check n plus 1 is equal to 0. The check thing is every element will have 0 frequency, and once we find something, we are going to make it 1. Okay, that so we can detect the first non-negative number, and answer n is the array that I am going to return it. So since it has been sorted, so we have to search from the largest number. So I is equals to n minus 1, I greater than equal to 0. So we traverse from the back and check a of I is equal to 1. That is, in this check thing, in this check array, in the frequency array or this check thing, check array, you're making the a of ith position is 1. That is, a of I is present. Okay, a of I is present. So while check of k is equal to 1, k plus plus. And answer of n minus I minus 1 is equal to k. I'll tell you why we do this. So 0, 2, 1, 2. If we like sort it, it becomes 0, 1, 2 only. And then the check array looks somewhat like this. Okay, since it is of size n plus 1, so it will be 1, 2, 3, 4. Okay, and all are initially 0. First we see 2 is there. Okay, so 0, 1, 2, 3. So since 2 is there, we make it 1. And k was initially 0, right? So it is initially 0. Okay, the first, so k points over here, right? K points over here. So it is initially 0. So first of all, we are going to print 0. Okay, done. Then we check 1, and 1 is present, so we make this 1, and k is equal to 0, right? So again we print 0. Then comes 0, so we make this as 1. But since now this is 1, so k is not pointing to a 0 element, so we have to increment k until and unless it is pointing to a 0 element. That is, while check of k is equal to 1, k plus plus. So this becomes over, this comes over here, and over here finally. So this is 0, right? This is pointing to what? 3. So this becomes 3. Okay, this check thing is just to find the max. Okay, max portion. This was also an easy one. Let's go to the last one. This was a little bit challenging, but I found it really a nice problem. Okay, so this is a equal grouping problem, which states that you're given an array and you can select a sub array of even length and remove the sub array if the elements in it lies from the range from 2 to the power I to 2 to the power I plus 1 minus 1, right? Now see, there is one thing similar in this thing, that is this portion. Okay, this portion 2 to the power m minus 1, this thing. Okay, so what this basically means that both their binary representation will have equal length, right? Both the binary representation will have equal length. And how can we find the equal length thing? Obviously log thing. Okay, so first of all we can, okay, let's not consider this first. So I is equal to 0, I less than n, I plus plus. We are replacing a of I with log 2 of a of I, right? So that we can find out at what should be the value of I such that that element lies in this range. Okay, so like say for 7, the value of I should be like log 2 of 7 is 2 to the power 4, 4 to the 8. So it's 2, right? It's 2. Now see, 2 to the power I, that is 4 to 2 to the power 3, that is 8 minus 1. See, it lies in the range from 4 to 7, right? So we get it. Okay, you get it, right? Why are we doing this? So we know that what should be the value of I such that we can delete that. And once we are done with it, we are going to use a stack. Okay, stack and top is equal to 1 minus 1. You know this basic rule of stack. What we are doing in stack basically is we are going to insert elements. Okay, insert the elements one by one, and if there is a repetition, okay, if there is a repetition, then that means that for one element, once it is inserted, there is another element which can delete it, right? So we are going to pop it. That is, we are going to, this thing has been given as even length. You can delete even length, but we are not considering that even length thing. We are just considering it that we can, since it is even, so we can delete it in groups of 2. Okay, in groups of 2. So like what this basically means is for 7, 8, 6, 4, we can delete 6, 4. Okay, so the remaining element, there are 2 elements, so that is 2. For 1, 7, 2, you have seen that 4 to 7 occurs. For this 4 to 7, so this can't be deleted because 1 also doesn't lie in 4 to 7 range and 2 also doesn't lie in 4 to 7 range. And since these two are disconnected, so there is no way to delete any element. So that is 3. Okay, so let me tell you what happens basically. So 7, 8, 6, 4. For 7, 8, 6, 4, this becomes replaced as log 2 of that. Okay, so 7, as I did earlier, okay, it becomes to the 4, right? 4, it becomes 4 to the 4, 4 to the 8. So this is 3. This is the log 2. Okay, log 2 of all the elements, and this becomes, sorry, this is not 4, this is 2, right? Yeah, this is 2. Yeah, so 2 to the 4, right? 2 to the 4, 4 to the 8, 2 to the 4, this becomes 2, and 2 to the 4, so this becomes 2. So what we are going to do, we are going to make a stack, insert 2, insert 3, insert 2, and now there is a 2. We are not going to insert it because 2 and 2 cancels out, so we are going to pop this out. Okay, so how many elements are left in the stack? 2. That is, you are going to return k plus 1. That is let's say, since this is 0 based indexing, so whatever top points at, we can return top plus 1. Oh sorry, this is not k. Okay, this is top plus 1. This is also not k, this is top. This is also not k, this is top. This is also not k, this is top. Okay, so let's go to this portion. I is equal to 0 to I less than n. If top is equal to minus 1, that is, you know that if the stack is empty, then no matter what, we have to insert the element, right? We have to push it. So we are going to push it. Else, if stack of top is equal to I, that is, the top element and the ith element are both equal, then we have to pop it, right? So top minus minus. Else, stack of plus plus top is equal to a of I. That is, we are going to insert it. Like let's add another element. Okay, let's say there was 9 in this. Okay, there was 9 over here, so that would make it 3, right? So now see, for 3, once we encounter 3 is in the top, so we can pop it out. So at that position, 2 would have been the answer. Sorry, this 1 would have been the answer because there is only one element left. Now let me tell you how. See, 6 and 4 we can delete, so now the new array becomes 7, 8, 9, and then we can delete 8 and 9, so the new array becomes 7. Okay, you get it? Like, this is the use of stack. This is the basic code. So these are the 3 problems. So yeah, all the best. I think you are also going to make a podium finish, right? So yeah, that's it. Thank you.